Okay, so we already know our value for LL. So our LL is equals to 45.33%. Okay, so we have already LL 45.33%. Okay, next. We need to compute for the plastic limit. So we have here the data for plastic limit. So here. So for number 2, solve for so we have L. So same with the liquid limit, we need to solve first for the moisture content, and then we're going to compute averaging of the moisture content to get the plastic limit. So let's try to solve for test 1. Test number 1. So what we need here is get the weight of the water, and then weight of the solids, soil solids, and the moisture content 1. So from the table here, we have 22.10 minus 20.42. So this yields 1.68. And then we have for the weight of the soil solids, we have 20.42 minus the weight of the container, 13.07. So this is equals to 7.35. So this is in terms of grams, okay? And then we have the moisture content, that is 1.68, our weight of water divided by weight of the soil, that is 7.35 multiplied by 100. So this is equals to 22.86%. So this is our moisture content 1. Next, for test number 2, we have weight of the water, weight of the soil solids or the dry soil, and then the moisture content 2. So our weight of water for test 2, we have 21.77 minus we have 20.19. That's 20.19. So this yields 1.58. And then we have for the weight of the dry soil, we have 20.19 minus the weight of the container, that is 13.18. So the value is 7.01. 7.01. So for the moisture content for the test 2, have 1.58 for weight of water all over 7.01 for weight of the dry soil times 100. So this is 22.54%. Okay, so now we're going to solve for the PL. So the PL for the plastic limit is equivalent to the average water content of the soil samples. So the average water content, have the value here, 22.86 plus we have 22.54 divided by 2. So we have L That's equivalent to 22.7. 22.7%. So this is our plastic bin. Okay, then we're going to solve for the liquidity index or LI. So number 3. So we have LI. So the equation for the LI is we have I is equals to the natural water content minus the plastic limit all over speed limit minus plastic limit. Now in this case, we need to solve for the in situ moisture content or the natural water content. So we have here the given. Okay, so let's take a look at the value here for the natural water content. We have 2 tests conducted. So we have going to solve for the moisture content for test number 1. So we need again weight of the water, weight of the dry soil, and the moisture content 1. So we have for test 1, we have 17.94 minus weight of the dry soil, 14.84. So this is equals to 3.1. And then we have 14.84 minus the weight of the container, that is 7.4 grams. So this is equals to 7.0 grams. And then we have 3.1 weight of water divided by 7.0 times 100%. So our moisture content 1 is 44.29%. For our test 2, so we have weight of water, dry soil, and the moisture content 2. So the value here, we have 17.39 minus, we have 14.36. Then we have 14.36 minus the weight of the container, that is 7.5. So the weight of the water is equivalent to 3.03. Then we have here 6.86. So we have 3.03 weight of water divided by 6.86 weight of the dry soil times 100%. This is equals to 44.17%. So how to solve for the natural water content? Let's denote this as NWC. So this is just simple as average of the moisture content. So this is equals to, we have 44.29 plus 44.17 divided by 2. So our natural water content is 44.23%. So this is our natural water content. So we can solve now for Li. So we have our Li, which is equivalent to moisture content or in situ natural water content minus PL or plastic limit all over LL minus PL. So we have Li So let's substitute the values. So we have our natural water content of 44.23 minus the plastic limit that we solved a while ago, 22.7. So we have 20.7 all over our LL, that is 45.33 minus PL 22.7. So we have 0.951. So our LI, by the way, we can check the description from our lecture. What is the meaning or what is the interpretation of this value? So when we say liquidity index, this is 0.951. This is lesser than 1. So we have there in the description on if LI is LI. So we have Li that is greater than 0 but lesser than 1. So in this case, the soil is plastic state. Soil is at plastic state. So in this case, we have value here 0.951. This means that our soil, therefore, soil is plastic state. Okay. So that's our Li. Here's our third problem.